Once again, welcome all students. So we are discussing the last part or to evaluate the integral by using the third definition of beta. So once again, I recall that last example. Once again, I will write. So what do I written? Integral 0 to infinity. This we have completed and that task I was given as a homework. Whatever the number you may continue. Suppose here I will use a fresh number as a 1. So you have to prove that the given integral 0 to infinity x raised to m minus 1 plus x raised to n minus 1 divided by 1 plus x raised to m plus n integral with respect to dx is nothing but beta of mn. Okay, I think that we have seen the last example. If required, I will show that. This one 0 to infinity. Okay, now here once again I written that because with reference to that I am going to continue with the second example. So second example, so what I will do, only I will change the limit. Prove that integral from 0 to 1. So what I did here, so instead of infinity I am taking 1 and rest of the thing same. Suppose x raised to m minus 1 plus x raised to n minus 1, that whole divided by 1 plus x raised to m plus n dx. I think in the earlier case someone should tell it is 2 times, and in this case it is beta of mn. It is a beta of mn. So once again I will I'm telling that I'm using only single screen only, so that's why I can't see the list of participant and I'm in the presentation mode. So that's why if you know the answer, reply quickly. So what I will do, procedure is same. Suppose I will call the given integral as a I. So let integral I as a 0 to 1 x raised to m minus 1 plus x raised to n minus 1 divided by 1 plus x raised to m plus n dx. So what we did in the last step, yes, anyone can reply. That means I will get, I am connected with all of you. What we did in the last step, last example. What we did in the last example. I hope that I am connected. Huh? I am audible?
Yes, sir.
Okay, fine. So what we did here? What we did here?
Write separately.
Yeah, you have to use the linearity property. This can be written as sum of two integral. So this can be written as integral 0 to 1 x raised to m minus 1 divided by 1 plus x. Same steps I am going to follow, only change is in the second last or last step, dx plus, so that's why the earlier example I have given as a homework, 0 to 1 x raised to n minus 1 divided by 1 plus x raised to m plus n dx. So once again I will call this as sum of two integral I1 and I2. Suppose this I will call as a I1 and I2, and this equation I will call as a number 1. So that I am going to refer afterwards. So I will use the same substitution and I will simplify integral I1. So where this integral I1 is given by, instead of 0 to infinity we are having 0 to 1 x raised to m minus 1 divided by 1 plus x raised to m plus n into dx. Yes, anyone can recall what is the substitution in the last case? That same thing we are going to use, put. Yes, anyone? X is equal to, what is the substitution?
X is equal to t by 1 minus t.
Yes, x is equal to t divided by 1 minus t. So that is our substitution. Remember that same substitution I am using. Remember that same substitution I am using. Okay. X is equal to t divided by 1 minus t. Then immediately without calculations we have seen what is the dx. Yes, anyone? After lunch there should be interaction. What is dx?
dt divided by 1 minus t whole square.
Dt divided by 1 minus t its whole square. Now for the limits, that limits I will write in the tabular form. X and t. When x is equal to 0, what is t? When x is equal to 1, what is t? That we have to identify. So think on the second case. When your x is equal to 1, what is your t? Now first one, can anyone tell what is value of t when x is equal to 0? This one you have
0.
this one you have to simplify. Okay, 0 is equal to t divided by 1 minus t. So by taking cross multiplication, 0 is equal to t, that means t is equal to 0. So lower limit 0. Now for the second case, what you have to do? That is 1. 1 is equal to t divided by 1 minus t. So try to solve this example for t.
T is equal to 1 by 2.
Very good. 1 minus t equal to t, or 1 is equal to 2t, or t is equal to 1 by 2. That is upper limit. So upper limit in this case, instead of 1, you are getting 1 by 2. Okay. So next, I will calculate that factor. So next, 1 plus x is given by 1 plus t divided by 1 minus t. Suppose if you take the cross multiplication, 1 minus t plus t divided by 1 minus t. Now here this plus t minus t get cancelled. If you simplify, it will come as a 1 upon 1 minus t. So this implies 1 upon. So what I am doing here, I am taking the reciprocal. So if I take a reciprocal, in this case, we will get 1 upon 1 plus x is equal to 1 minus t. Okay. Now I will try to simplify the integral. Therefore, the integral I1 is given by new limits of the integral 0 to 1 half. New limits 0 to 1 half. X is nothing but t raised to 1 minus t. This whole bracket raised to m minus 1. We are not necessary to use the bracket at 1 minus t. Okay, if I return, it's okay. So 1 upon 1 plus x is 1 minus t raised to m plus n, and that dx is nothing but dt divided by 1 minus t its bracket square. Now further, there is no any constant term, so it can be simplified as 0 to 1 half. There is a single term t raised to m minus 1. So can you tell what is the power of 1 minus t? For the first, you have to write in the numerator. It becomes minus m plus 1, minus m minus n, and minus 2 dt. That means, so I will scroll little bit off. That means I1 is equal to integral 0 to 1 half t raised to m minus 1. And what is the power of 1 minus t? Anyone? Something I made mistake? Definitely.
Sir, m plus n.
Yes.
In power.
Yes, this is plus, this is also plus. Now it's correct?
Yes, sir.
Okay. Now what is the remaining term then? N minus 1.
N minus 1.
Okay.
Minus 1.
Now similarly, can you tell, not necessary to solve second one. So symbolically I will write it this one. Similarly, that's I2 integral, or once again, just a minute, I will rub this whole I will write, since you would get clear idea. So I1 is equal to, what happening with this? Yeah. So I1 is equal to, what is that integral? Integral 0 to 1 x raised to m minus 1. I am not getting. Okay, x raised to m minus 1 divided by 1 plus x raised to m plus n dx, that you are reducing to the integral 0 to 1 half t raised to m minus 1 minus t raised to n minus 1 dt. Now further simplification is not possible because integrand we are getting in the form of beta. But what about the limits? For beta we are having 0 to 1. So that's why. So further simplification is not possible. That's why I will keep this one as it is.
Sir, I1 equals to in limits, sir, 0 to 1 we have to write.
Very good. 0 to 1. Yes, it is 0 to 1. 0 to 1. Correct. Thank you. Now the second one, I2 is, I2. Now not necessary to calculate I2 separately because you have to change the role of m and n. So I2 is nothing but 0 to 1 x raised to n minus 1 divided by 1 plus x raised to m plus n dx. Yes, anyone? What will be the limits? What will be the limits?
0 to 1 by 2.
0 to 1 by 2 in the same manner. So what is
T
t
raised to n minus 1.
Very good. T raised to n minus 1 and 1 minus t raised to
M minus 1.
m minus 1 dt. Okay. Therefore, I will substitute both values of I1 and I2 in equation 1. Therefore, equation 1 becomes, what I will do? I will substitute both values. Therefore, that integral I can be written as 0 to 1 half t raised to m minus 1 into 1 minus t raised to n minus 1 dt plus second integral is also 0 to 1 half t raised to n minus 1 into 1 minus t raised to m minus 1. So here I will give 1 or 2 minutes, think on that. So what ultimately I have to prove? At the end, I have to prove this integral defines, or the sum of both integral defines as a beta mn. Can anyone think on this and what will be the steps? I will write a property. Suppose a is less than c is less than b, then integral a to b fx dx. This can be written as integral a to c fx dx. This property you have to use plus integral from c to b fx dx. Suppose you have to use this property. And when you are using this property, one thing you can notice here, the integrand for the right side both must be same. But in our case, we don't have the integrand same. Can we make the integrand same? One more property you can consider here, by the definite integrals are independent of the parameters. Yes, anyone? Now see, ultimately this one I will write some different color. What I have to prove, this one is nothing but 0 to 1 t raised to m minus 1. Afterwards I am going to rub this n minus 1 dt. And this property you are going to use. 1 is plus, 1 is second. So for first integral, is it necessary to simplify anything? No, because the integrand is in the required form. For the second one, what should be the limit first? What should be the limit? What should be the limit? शेवटी लिमिट काय असणं अपेक्षित आहे? I will rub this part. For the second integral, you have to put that part. I will write here. For second integral, put, yes, what telling, 1 minus t is equal to any other variable x, or what is t then? 1 minus x. Okay, these are the substitution. Now given limits for t, when t is equal to, suppose this equation I will call as number 2, t is equal to 0 then what is x? Calculate kara. T is equal to 0, what is x? This substitution you can use. T 0 substitute केला तर काय होईल x? 1 येईल ना? 1. So t is equal to, next one is limit is 1/2. Then what is x?
1/2.
1/2. Okay.
1/2.
Therefore, the second integral, then only the second integral I will write. Then integral 0 to 1/2 t raised to n minus 1 into 1 minus t raised to m minus 1 dt can be written as new limits, I think 1 to 1/2. Here I forgot to calculate, I think dt. Here I will calculate. So this dt is given by minus dx. Okay. Now t is 1 minus x raised to n minus 1, and 1 minus t is x raised to m minus 1, and dt is minus dx. So this negative sign I will absorb for the limits of the integral. I will change the limits. So that integral can be written as 1/2 to 1. Now first I will write x raised to m minus 1, and the second one is 1 minus x raised to n minus 1 dx. And further we know the property of definite integral. So definite integral is independent of parameter. Otherwise, in other words, you can say put x is equal to t directly. Then same integral we can write 1/2 to 1 t raised to m minus 1 into 1 minus t raised to n minus 1 dt. Now I will write that equation number 2. Therefore, equation 2 becomes this I is equal to, first integral no change, 0 to 1/2 t raised to m minus 1 into 1 minus t raised to n minus 1 dt, plus second integral you have to replace as 1/2 to 1 t raised to m minus 1 into 1 minus t raised to n minus 1 dt. Okay. Now I will use this property. So by using that the property of definite integral, this integral can be written as 0 to 1 and 0 to 1/2. So 0 to 1/2 t raised to m minus 1 into 1 minus t raised to n minus 1 dt, and this is nothing but beta of mn. Therefore, the integral which is nothing but beta of mn, and I think that is your required result. Any doubt? These are the special kind of examples you have to remember. Whatever examples I am taking today, these are the specials. If not, I will continue with one more. Suppose it may be third. I am using 1, 2, 3. Prove that or evaluate, whatever. Suppose prove that integral 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 into, divided by a plus bx raised to m plus 1 dx is given as beta of mn divided by a plus b raised to m into a raised to n. Now first step I will write that integral as a I. Think on this and tell me what any steps you can suggest. Let I is equal to limits 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1, that whole divided by a plus bx raised to m plus n dx. Yes, any suggestion from your end? If any suggestions are there, I will take. Definitely it's difficult to identify. Okay, so for this example, you have to put x is equal to 80 divided by a plus b, that is a one term. If you look at the answer, we are having a plus b factor minus bt. So this is our substitution, that you have to remember. This is our substitution. Okay, this is our substitution. Now differentiate, because we require dx. For dx, you have to apply quotient rule. By quotient rule, a plus b minus bt as it is, differentiation of a into t is nothing but a dt, minus 80 as it is, and differentiation of the denominator, differentiation of a is 0, differentiation of b is 0, differentiation of minus bt is minus b times dt, and that whole divided by a plus b minus bt, its bracket square, denominator square. Is it okay? Further, if you simplify it, now while simplifying, I will take one term as a plus b, one term as a plus b, one term as a plus b. Why? In the required answer, we are having a plus b as a one factor, a plus b as a one factor. So that's why. So if you simplify this one, first one is a into a plus b dt minus abt dt plus abt dt, and that whole divided by a plus b minus bt, its bracket square. So here you can cancel this term, minus abt and plus abt. So the remaining, that dx is given by a into a plus b times dt divided by a plus b minus bt, its bracket square. Okay, now we have calculated here dx. Now again I will give some time to calculate the limits. For the limits, given limits for x 0 and 1, new limits for t. I am writing correct now? So take 1 or 2 minutes and tell me the limits. When x is equal to 0. Okay, this yes, this equation you have to simplify. 0 is equal to 80. Someone is unmuted. If you want to tell the answer, then it's okay. Otherwise, mute yourself. What is t? By taking cross multiplication, it becomes 0 into 80. So from this, what is t? At least tell the last step.
0.
Yes. So lower limit of the integral is 0. Now in the same manner, you have to simplify the second one. Now in this case, x is 1, which is given by 80 divided by a plus b minus bt. Can you simplify?
T equals to 1.
Very good, very good. Is it necessary to simplify? No, I think. Okay,
No,
new limits 0 to 1. Okay, now again, whatever the factors I required under the sign of integral, so that factors I will calculate separately. X, you are using a substitution, 1 minus x factor I required. So next, consider 1 minus x, which can be written as 1 minus x is given by 80 divided by a plus b minus bt, and by taking cross multiplication, it can be written as a plus b minus bt and minus 80 divided by a plus b minus bt. Now I will treat these as a two terms. This is first term and this is second term. Now from second term, I think minus t is common. So this a plus b, I will put a bracket, minus t into a plus b that whole divided by a plus b minus bt. And if you consider again, these are the two terms in the numerator, from that I will take that a plus b as a common. If you are taking a plus b as a common, then the remaining factors are 1 minus t divided by a plus b minus bt. Okay, so try to calculate the next a plus bx factor. Yeah, I think it's fine. Now, also, second one is, what is that factor? Also, a plus bx. What is a plus b? Oh, a plus bx only. So a plus bx is given by a plus b into, what is the value of x? It is 80 divided by a plus b minus bt. So by taking cross multiplication once again, so the denominator is a plus b minus bt. So if you take a cross multiplication, again while writing the factor, I will take a plus b multiplied by a. A into a plus b minus abt, and again plus abt multiplied by 1. I think here the term abt and minus abt get cancelled. Further, it can be simplified as a into a plus b divided by a plus b minus bt. So further simplification is not possible. I will stop here. So thus the given integral can be written as I is equal to new limits of the integral from 0 to 1. I will substitute all the factors. New limits are also 0 to 1. X raised to means 80 divided by a plus b. What is the term? Can anyone help? Minus bt raised to m minus 1. Now second one is 1 minus x factor, that is in the numerator only. 1 minus x factor raised to n minus 1. So this can be written as a plus b into 1 minus t, that whole divided by a plus b minus bt raised to n minus 1. And the next one, what is the next factor? A plus bx, and that term is in the denominator. That's why we have to take the reciprocal of this. So if you take the reciprocal, then it becomes a plus b minus bt, and that whole divided by a into a plus b. What is the power? M plus n. So raised to m plus n, and dx is a into a plus b, that factor is there, a into a plus b divided by a plus b minus bt, its bracket square, into dt. Okay, now I will scroll up. Now from this, what is the required answer? A and a plus b both are in the denominator. Okay, both are in the denominator. I will write. So I will take suppose first a to the power 1 by 1. Can anyone tell me? 1 by 1. Suppose first one, this term if you are writing, what is the power? Raised to m minus 1. A raised to m minus 1. Now next, after that we are having that term in the third factor, and that term already something I made mistake. You should rectify that. So that term I am writing in the denominator. That's why minus m plus 1. Correct na?
Yes.
Okay. Now the next one, the term is in the denominator. That power I have to write plus m plus n, and one more that is in the numerator, but I am writing in the denominator, raised to minus. Now see, I have taken a term. So after that I will take A plus B terms. I think here one term A plus B, here I am having one term, and here I am having one term. So that term you are writing in the denominator. Then A plus B raised to, yes. So this term is in the numerator, but I am to write in the denominator minus n minus 1. The term is in the denominator plus m plus n, and again minus 1. Is it okay? Is it okay?
Sir, minus n plus 1.
For which factor? A plus B. Once again I will check. So this term is in the numerator. I am writing in the denominator minus n plus 1. Very good. Minus n plus 1. I think, is it okay?
Yes, sir.
Okay. Now the remaining terms 0 to 1. Now under the sign of integral you are having three factor. First one is t term. I think there is only one t term. There is only one t term, and that is t raised to m minus 1. Only one. After that, suppose I am writing 1 minus t term, and that term I am writing in the numerator. So what is the power? 1 minus t raised to, I think that is also single term now, only one term, raised to n minus 1. After that, suppose a plus b minus bt, that term should vanish. It should come as a 1. Now simultaneously let me know the power. Different color, I will take some highlighting for that. Okay. Now here I am having that factor a plus b minus bt, and power is m minus 1. But that term I am writing in the numerator. That's why I have to change the sign. Minus m plus 1. So once again that factor I am having in the denominator. That factor I am in the denominator, and power is n minus 1. And that I am writing in the numerator. Again you have to change. Minus n plus 1. Now next one, that factor is in the numerator only. That's why that power I have to take m plus n. So that power is plus m plus n. And one more term, that is a plus b minus bt, and raised to 2. Raised to 2. But that you have to take in the numerator. That comes as a minus 2 dt. Now tell me, after simplification, what is the power of a? A raised to, I think
N.
minus m plus 1 minus 1 get cancelled, a raised to n, and that is the required answer. Now the next one is a plus b. Once again you can cancel the terms. I think minus n plus n get cancelled, plus 1 minus 1 get cancelled, remaining is m into integral 0 to 1. Integral 0 to 1 t raised to m minus 1, 1 minus t raised to n minus 1. What is the power of the second term?
0.
It's 0. And anything raised to 0 is 1, so not necessary to write. You can verify that. Okay. Now you are getting the next step as a required answer. It is a raised to n into a plus b raised to m, and the second is nothing but beta of mn. That second integral defines as a beta of mn, and that is the required answer. Okay. Now this is the end for a special function, or we can say beta and gamma. So still we are having 10 to 15 minutes. I will take an example. Suppose just a minute. So some more examples on the properties. Only 2 examples I will take, and I will stop here. This is, I think, fourth example. So these examples are based on the property of beta mn. So prove that. Beta of mn is given as beta of mn into multiplication is there. Beta of mn into beta of m plus 1 half and m plus 1 half. If you take multiplication of these two beta, it comes as pi divided by 2 raised to 4m minus 1 into 1 upon m. Okay, if we will get something different, we will modify that. So simply these examples you can consider these as a type 6 or 7. What is the number? I think 7. And these are based on the property that beta of mn is given by gamma m gamma n divided by gamma of m plus n. Okay, to prove this I will continue with LHS. So let LHS is equal to beta of mn into beta of m plus 1 half m plus 1 half. Simply I started with that property. Now next one, that LHS, and next one I will apply the property. This will I will write as gamma m into gamma n divided by gamma of m plus n. Okay. Second one, gamma of m plus 1 half. Second one, gamma of m plus 1 half. So once again, gamma of m plus 1 half divided by what is the sum? What is the sum? M plus m is
2m plus
2m.
1.
Yes, 2m plus 1. 2m plus 1. And we have studied one property that I will write. That what is the name? It I think duplication formula. We have studied duplication formula for gamma function. Yes, anyone can recall what is the formula? It is 2 raised to 2m minus 1 gamma of m into gamma of m plus 1 half, and that can be written as gamma of 2m into, you should recall these. So suppose in the numerator what happened, one is gamma m and one is gamma n. So that LHS I will simplify as how to proceed further. How to proceed? Yes, anyone? I will correct the statement because I am feeling difficulty. This one is m, not n. I will correct it. This one is m, then this one is also m, then this one comes as a gamma of 2m. Otherwise it becomes difficult to simplify. Now next step, see what I am writing here. Also I have to write then m. So it can be written as gamma m into gamma of m plus 1 half divided by, remember this gamma of 2m plus 1 can be written as 2m into gamma of 2m by using the property. So from that, so that gamma 2m I will take. That means each term coming 2 times. So that's why I will write it as a whole bracket square. Each term coming 2 times, and the remaining is 1 upon 2m I will write as it is. Now by using duplication formula, I will highlight the terms. Gamma m and gamma m plus 1 half divided by gamma of 2m is nothing but root pi upon, this you have to simplify, root pi upon 2 raised to 2m minus 1 its bracket raised into 1 upon 2m. Sorry. If you simplify, you will get the required answer. It comes as a pi. Now tell me, 2 raised to 4m, this one is 4m minus 2 into again 2 multiplied by 1 upon m. So one more step you can simplify. It will be written as pi upon 2 raised to 4m minus 1 into 1 upon m, and that is your RHS. That is your RHS. Simply you have to use the property. Okay, hence the proof. Hence the proof. Now one more, last example, and I will stop. Suppose you have to prove, that is whatever the number you continue. Fifth example, prove that beta of x and x is equal to 1 upon 2 raised to 2x minus 1 into beta of x and 1/2. In the same direction you have to go, in the same way you have to go. I will consider with LHS for this. Consider LHS is equal to beta of x and x, and by using relation between beta and gamma function, I will write it as gamma x divided by gamma of 2x. Okay, and once again you can reply the duplication formula. It is 2 raised to 2m minus 1 gamma m plus 1/2 is equal to gamma 2m into root pi. Now in this case I will highlight the term. So this gamma m upon this root 2 gamma, this term. So this term I will replace. Therefore it can be written as 1 gamma x as it is, and for the highlighted, for this term I will write it as root pi divided by 2 raised to 2m minus 1 into gamma of m plus 1/2. No, not m. So sorry, I have to replace that parameter. Instead of m, I have to write x. I will correct it. 2 raised to 2x minus 1. 2 raised to 2x minus 1 into gamma of x plus 1/2. Now further, it can be written as 1 upon 2 raised to 2x minus 1 into, I will write this as a gamma x, root pi I will write as a gamma 1/2, and divided by gamma of x plus 1/2. And here I will use the property in reverse order. So this outside 1 upon 2 raised to 2x minus 1 there, and it can be written as beta of x and 1/2, and which is your RHS, hence the proof. Okay, so here I will stop.